Hi everyone, welcome to Geek Coding Academy. Today we'll see Collection Framework Chapter 6.5, that is Map Interface and its implementations. So let's see. So in our previous classes, we covered all of these concepts like list interface, set interface, and Q and DQ interface. Today we'll see about map interface and its implementation. Okay. So in a collection framework, we have two parent interfaces, main interfaces. One is collection interface and another one is a map interface. We covered all the sub interfaces of this collection interface and the classes which are implementing these interfaces in our previous videos. If you have not watched that video, please go and watch that video prior to this. In today's session, we'll cover on this map interface. What are the implementation classes for this map interface and when to use this map interface. We'll see in this today's session. So let's get started. So what do you mean by like map interface? Like how it is different apart from collection interface, okay? So I already told in the collection framework, there will be two interfaces. One is collection interface and another is a map interface. How it is different is the way of storing data. So in collection interface, like we are storing individual data, but here in the map interface, we need to store data in terms of key value pairs. Okay. There will be like one null key is allowed, but value may be duplicate, but key should be always unique and only one null is allowed in map interface. The way of storing data is completely different here in map compared to collection interfaces. So let's see. So map interface is a part of Java collection framework. It's a part of Java collection framework and it represents a collection in a key value pairs. Okay. So each key in a map must be unique, but the values may duplicate. Okay. Common implementation of map interfaces are HashMap, LinkedHashMap, TreeMap, Hashtable in EnumMap. Okay. Some of the common implementation which I'm talking about here with a different characteristic for each one. So we'll see what all these. So first of all, map store data in the form of key value pairs. Okay. It provides several methods to manipulate these pairs like adding, removal, searching for entries based on these keys. What is a key characteristic of map? Keys must be unique. Okay. In map and its interfaces classes, if we are using for our managing our data, then like whatever we are making them keys should be unique. Value may be duplicated because we are addressing with the help of keys in a map interface or map type of collection. So map is not part of a collection interface. I already told collection framework as a two sub branches. One is collection interface and second one is a map. Because why we separated map from collection interface is in collection interface the way of storing data is individual, but in map the way of storing data is in a key value pairs. Okay, but it's a part of collection framework. Okay, so common methods in map interfaces. Put. So put is a method which will use to add a key value pair into map. Get. So get method retrieves a value associated with a specific key. Remove, which removes the object in the collection. Contains key. So it will check the map containing in a particular element, a particular mapping for a specified key. Contains value. Like it check the map contains one or more mappings of a specified value. Suppose like contains key, only one data will get, but contains value maybe have a multiple duplicates are allowed. So we may get one or more mappings of the specified value. Key set means it returns a set view of keys contained in a map. Like what are the keys we have in map? It will be converted into a set, means set view will get if you use that method key set. Values is a method which will return a collection view of a value contained in a map. So entry set which will return set view of mappings, both key and value mappings in a set view. Like in our previous class, we discussed about set interface, like set data type, like how we need to use set and everything. Please go and watch, like you have a complete idea of how set and how set works. Set view of a mapping contained in a map. So common implementation of map interface, like map interface may have a sub classes, more subclasses. In that, I have picked out of those, I have picked these 5 commonly used implementation of the map interfaces. What all that is? HashMap. You guys may heard of this. So whenever you are using, we simply use an HashMap. That's one of the most common implementation. LinkedHashMap, TreeMap, Hashtable, and EnumMap. Okay, let's see one by one. So what do you mean by an HashMap? So HashMap class which uses a hashtable concept to store a key value pairs. So it provide O of one. That means constant time for basic operation like addition, insertion, addition, deletion, or retrieval get operations. Assuming that hash function of a element are properly across the buckets. That means like what is hashing? There will be an hashing algorithm based on that the data will be stored in HashMap. Like if the mapping that algorithm will provide a unique IDs for each of the data. If two data will get a same IDs, then there will be a possible of collision. That's we called as an hash collision. This and all concept I will cover in the future videos. But now you understand like how hash maps works. Hash map works based on this hashing principle, and it uses an hash table to store key value pairs. Okay. And the main thing is hash map uses constant time O of one for basic operation like insertion, deletion, and retrieval of data. So this is a syntax of an hash map where I have a main class and I written a main method here, public static of void main. So here I created an hash map object using new operator, and I'm passing to the reference of map reference because HashMap is the implementation class for map interface where map the type of data I'm storing here is string and integer. Like two data types I provided here, the type of data. Why? Because here the type of uh, the way of storing data is in a key value pairs. So what I mean is keys of type string and values of type integer. So we use put to add a data to this HashMap collection. So HashMap dot put apple 1, HashMap dot put banana 2, HashMap dot put cherry 3, HashMap dot put apple 4. Yeah, here what we are trying to do is apple is a key and its value is 1, banana 2, cherry 3. And finally, again, we are going to put a apple with 4. That means like already the key is already available in a in our collection apple. Again, we are trying to add an apple another key. So I already told keys must be unique. No duplicates are allowed in keys in HashMap, such that this will what it will do is it will replace the already existing apple. Okay. So after that, when we print an HashMap, we'll get a apple as 4 because the older value will get completely replaced. Okay. So key feature for this is it does not maintain order of keys. Like suppose we are adding, right? Like it will not maintain the insertion order. Allows one null key is allowed and multiple null values are allowed because one null key is allowed and it considered as unique. When come to a data, duplicates are allowed. So it is a best choice for fast lookups when order does not matter. I mean, like when suppose in our application where we don't want to consider insertion order, just we want fast lookups like addition, removal, or retrieval of data, we can use an hash map because its time complexity is of one. So what do you mean by linked hash map? So linked hash map is an extension of hash map with an additional feature. What additional feature is? It will preserve the insertion order. Hash map does not preserve insertion order. That's the only drawback in HashMap. But in linked HashMap, if you use, it will preserve the insertion order of keys. It combines the concept of both as table and linked list to achieve this ordering. Okay. So this is the syntax for a linked HashMap where I have created a linked HashMap object which is of type string and integer. Similarly, how we created for an HashMap. Using put, we can able to add data to this linked HashMap. I initially added apple with one value is one, keen banana with a value two, cherry with value three, and again I'm trying to add an apple with four. It replaces the already existing record that is apple with one because the main concept in entire map is duplicates are not allowed in keys. Again, when I print the linked hash map, I'll get apple, banana, and cherry. Okay, the order is preserved. Okay. Yeah. So it maintains the insertion order, similar performance to HashMap, but with a slight overhead due to linked list. It will same performance with the HashMap, like how HashMap works, but it was slight slower compared to an HashMap. But that's okay. If want a, our data where insertion order is must and should we need to keep or we need to track, then we can go within a linked HashMap. So let's come about tree map. What do you mean by tree map? So tree map stores key value pairs that we know in a sorted order of keys. In a previous video, we talked about tree set, where tree set is also, it will sort. Similarly, tree map, it will insert data in a sorted manner. It's okay. It uses a red black tree for storing data. What is that red black tree? When we went to the data structure and algorithm classes, I'll explain you about those. It provide a O of n, sorry, O of log n for basic operation. Okay. The time complexity is logarithmic time complexity. It will, if use this tree map. Okay, I have created an object tree map here, and I try to add a data banana 2, apple 1, and cherry 3. When I print this tree map, automatically it will be sorted based on ascending order of these key names. Okay, so maintain natural order of keys by default ascending order. If we can also give our own custom comparator for sorting, and it does not allow null values. Okay, but allows multiple. Sorry, it does not allow null keys. Not even one null keys are allowed because it should have to sort with other keys, right? Like while adding. And ideal when you need to, it will be useful when you want to have a sorted map behavior. Hashtable. So these are all legacy classes that also implements an map interface. It's similar to an hash map, but a synchronized version. What is synchronized means? It's a thread safe. Means when operation is going on, like until the finish of that operation, the resource will not be released. So what is thread locking, and what is synchronization? We'll talk about when we went to thread concepts. That the immediate next chapter of this after this collection. So Hashtable like it's a legacy classes and it's a synchronized version, but it's works similarly like an hash map. So it's a thread safe because it's synchronized for concurrent access, and it does not allow null keys. Not even one null keys also it will allow, and null values also it will not allow. This is in a syntax for an hash table where I created an hash table object, and it will be passed on to this hash table reference variable, which is of type string and integer. And I try to put a data to it like apple 1, banana 2, and cherry 3. And I print it, it will be like all data what we have entered apple, banana, and cherry. Because it's synchronized, making it slower compared to an hash map, like because it is a single threaded environment. Like in a single threaded environment, this if you use a hash table, like thread will be locked, and until unless a completion of this, there is no other process can take it, can happen simultaneously, and it does not allow null keys and null values. Okay, concurrent hash map in place of an hash table for mortal multi-thread operation. So in order to do like if for example normally we in the modern application we have a multi-threaded concept, we can use concurrent hash map. Okay, instead of this, let's see EnumMap. Like how we saw in our enum set, this EnumMaps a similar way, like it will look into an enum constant. EnumMap is a specialized implementation of map designed to use with an enum keys. Okay, enum keys are enum constant. It's highly efficient because it uses internal use an array, bit vector concept, and memory we need to use when our system or an application is deploying in a system where like memory and time both should be taken in consideration. We can go with an EnumMap. It internally uses an array and guarantees constant time performance for operation. So this is a syntax of this EnumMap. First, we need to define an enum constants or enum keys. Up to I am taking a day, which is of type enum block, and I'm just creating Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. These are all the keys of enum. After that, in my main method, I'm created this enum map using this reference date dot this enum reference. I'm passing up here. So after that, when we're putting a data to it, I just point out to the constant as enum keys along with the value which I want to add for the particular key. When I print, I'll get an output of Monday, start of the work week, Friday, end of the work week, Saturday, weekend. So it only works with enum keys that we know, because we have to define, and it's more efficient than other map implementation for enum based data. Okay, and keys are maintained in their natural order as defined by enum. Like how we defined by enum, in that order keys will be kept. Okay, so let's see the what is the difference between all these which we discussed so far. For hash map, let's take an order of insertion. For hash map, there will be no preserve of order of insertion. Linked hash map, yes, linked hash map will preserve the order of insertion. Tree map, it's sorted, like there is no concept of order of insertion, like it will be sorted by keys. By default, it's a natural order. That means ascending order. If you provide any custom comparator, it will sort the data based on that. For hash table, it will also not keep any order. For EnumMap, it's an order of enum keys which we define. Null keys, one null key is allowed. In link dash map also, one null key is allowed. All other null keys are not allowed. Null values of HashMap, LinkedHashMap, and TreeMap, null values are allowed, but in Hashtable and EnumMap, null values, sorry, in Hashtable, null values are not allowed, but EnumMap allowed. But we need to define that in an enum keys. Sorry, enum. Um, okay, in value it was allowed, but in keys it should look up into an enum. Called synchronized. That means thread safe. HashMap, LinkedHashMap, TreeMap are not thread safe, but Hashtable is a thread safe. EnumMap is also another thread safe. Performance wise, HashMap is constant O of 1. It's very good for basic operation. Linked HashMap is also O of 1. TreeMap is O of log n for basic operations. Hashtable and EnumMap is O of 1. Use cases means like general purpose, we can use HashMap. Linked HashMap when we want to go is for a general purpose, but the insertion order we need to preserve. But TreeMap, when sorted is required, okay, we need to add a data. The data should be automatically sorted. Then we go with a tree map. As table is a legacy class, it's a thread safe, but no nulls are allowed. Like enum map, we have to go with the enum based data. Okay. So these are all theory, guys. So let's go to practical. So I created a class called map implementation demo. In map implementation demo, first I created an enum of day where Monday, Tuesday, Wednesday, Thursday, all constant keys I have defined here. After that, in my main method, I created an hash map where it will be the reference of this will be taken care by this hash map reference variable. This is of type map, and I defined string and integer. That means like first value will be key and key type, and second value will be value type. Key type I'm always providing it is in a string type, and value type will be an integer type. Using an input method, I'm trying to add a data to it. Apple, banana, and cherry. When I print the hash map, I'll get in a same order like apple, banana, cherry. But suppose let's go to in a second implementation, link dash map. In link dash map, new of link dash map. Similarly, like I created an object, and using that object, I am trying to like reference of that object, I'm trying to add a data to it. Apple, banana, cherry. When I print it, here the insertion order is preserved, but in hash map, insertion order is not preserved. It's the only difference between hash map and link dash map. For tree map, it will be sorted. In tree map, first I added banana, later I added apple, and later I added cherry. But when I print it, it will be based on ascending order, like alphabetical order, apple, banana, and cherry. For Hashtable, it's a legacy class. It's similar to an HashMap only, but it's a legacy class. But here, no null values are allowed, and it's a thread safe. So I put a banana, apple, banana, and cherry. All will be printed upon here. So EnumMap, it will look up the keys in the enum which we defined here. So I created an object for it with a reference of that enum day, which we created, and enum.put Monday, Friday, and Saturday, all this. And I'm trying to print the value of it. Let's print the value. Let's run the program and we'll see. As you can see, hash map, apple, cherry, and banana. But we are trying to add apple, banana, and cherry, right? Like, but it's insertion order and it's not preserved. Like wherever it can store, like automatically it will scramble in an hash map. But for a linked hash map, banana, apple, and tree. Uh, just a minute. Yeah, yeah. Sorry, sorry. For linked hash map, apple, banana, and cherry we added. apple, banana, and cherry. The insertion order is preserved. For tree map, we added banana, apple, and cherry, but apple, banana, cherry. It will be sorted based on ascending order by default. If you provide our own custom comparator, it will sort based on that. And as table, banana, apple, banana, and cherry. This also insertion order is not preserved, but it's a legacy class. It works similar way with how HashMap works, but it's a thread safe. For the enum, Monday, Friday, and Saturday. Monday start of the work, Friday end of the work week, and Saturday is weekend. So it will print the values which we added. So guys, these are all about map interface and its implementations. In our next class, we'll see more advanced concept of this collection framework. Thanks for watching. I'll meet you guys in my next video. Till then, keep watching, keep learning. Thank you. Bye.